The challenge questions 2 and 3 are the ones that actually require a little bit more brain power because they are not ready to go. They look different than all the other ones that we did. So number 1, it kind of looks the same. It's just like lots of X-intercepts. So it's like, okay, I can do it the same as the other ones. It's just annoying. I just have to be more careful. 2 and 3 are actually a different process. So to do number 2, you have to factor it before you get started. They did not put it in the correct linear factorization form. They left it a little bit factored, a little bit multiplied out, so it is not ready to work with yet, and there was no other problem in the packet that was like this. So how could you factor the first quadratic? So ignoring the second one, how could you factor that first quadratic? X plus 2, x plus 2, right? So 2 numbers that multiply to 4 that add to 4 would be x plus 2, x plus 2. And then if you factor x squared minus 4, what would you get? The difference of squares, x minus 2, x plus 2. Okay, so if we were to take all of that stuff, all those factors, and kind of put it together, we would say this is x plus 2 to what power? Cubed, because there's 3 of them. 1, 2, 3. Okay, and then x minus 2 to the 1. So, and then it's like a regular problem. So the hard part wasn't actually graphing it from the factors. That part's not bad. It was figuring out what the factors are to begin with. So from there you can go, oh, this is a degree of 4. It has a positive coefficient. There's no negative sign. So if it has a positive coefficient, what does that tell us about the arrows? Up, up. Both of the arrows are going to go up. Okay. We have an x-intercept of -2 and an x-intercept of +2. What is the multiplicity of the x-intercept of -2? Multiplicity of 3. What is the multiplicity of the x-intercept of +2? 1. Okay. So we've got up arrow, -2, +2. Okay. So for a multiplicity of 3, should it go up, level off, go up? Or should it go down, level off, go down? Which one? Down, level off, go down. So we're going to have the arrow, go down, level off, go down. Okay? And then for our multiplicity of 1, should we have a positive slant for our slope? Or should we have a negative slant? Which one makes more sense? Negative slant? You're going to connect and do a negative slant? Oh, I said negative. Ooh. Sorry, my migraine is affecting my hearing, so. Yeah. We're going like almost 3 weeks strong. It's solid. Yeah, my brain hurts, like my head hurts right now. Like right behind my ear. So I messaged my doctor and I said, doctor. So that's what I call her. I said, doctor, can I try magnesium? And she did not respond. So I waited a few days and then I started it today, but apparently it takes a while to impact you. So, all right, so that's what it should look like. So the graph itself wasn't too bad. It was just the factoring part before we got started. Same thing with the next one. So we have difference of squares right here, but that thing is squared. So if you factor x squared minus 1, what are those factors? What's x squared minus 1? X minus 1, x plus 1, but it's that squared, so that means you have 2 of those. So you have x minus 1, x plus 1, but then because it was squared, you have another one. Is everyone comfortable with that? I have 2 sets of that because it said squared, so I have to write it twice. So the difference of squares was squared. So it's 1 set and then another set because it was this squared. So 1 set and then another set because it was difference of squares squared. Yes. I mean, it wouldn't be outrageous for me to put one on there. You factored before. You have factored. Has anyone been working on a cheat sheet for this unit? You can have it for the quiz. Yeah? Yeah. I said assessments. Is what? No, but let me... Well, the review is going to be accurate for what is going to be on it, but let me see if I have... I don't have a list of suggestions. I don't think. Polynomial functions. I don't... Oh, cheat sheet suggestions. I could print this for you guys. Yeah, I'll print this for you. There you go. That makes your life easier. So, it's not for a grade. It doesn't have to be perfect. You can do the things I suggest and some extra stuff. It's whatever you want, but it's 1 sheet of paper front and back. Biggest it can be is 8.5 by 11, which is standard printer paper. All right. I would recommend it, though. What I've noticed in particular, the reason I'm letting you guys use a cheat sheet for this unit is that the concepts in this unit tie together, but they feel abstract to you guys, which means that you guys tend to forget. So the cheat sheet is to help you guys remember things that when you panic, your brain would forget them. Does that make sense? So mathematically, they do tie together. But for whatever reason, in this unit in particular, the stuff goes out of your brain. Yes? No. Thank you for bringing it up, though, so I could say no before you did it. Yes. Yeah. Yeah. So tomorrow's going to be a quiz review and a quiz on the same day, so I'm going to give you the quiz tonight, or the quiz review tonight, so you guys can look over it and do maybe some of the easy questions, and then you'll know which questions to ask me about tomorrow. You'll know like which ones to make sure you have time for in class. All right, we still haven't factored the second one. So for the second one, we're looking for what multiplies to -4 and adds to +3. What are the numbers that do that? Say it again. 4 and -1. Okay, so if we write this in the factored form, we have x minus 1 to the third, 1, 2, 3, x plus 1 to the second, and then x plus 4 to the 1. Okay, so what's the degree? 6. It's got a positive coefficient, so what are the arrows going to be doing? Both are going to be up, okay? We have an x-intercept at +1, -1, and -4. At +1, the multiplicity is 3. At -1, the multiplicity is 2. At -4, the multiplicity is 1. So at -4, should we have a positive slope or a negative slope? We should have a negative slope. That makes more sense. Okay. At -1, should we have a little parabola sitting above the x-axis or a little parabola sitting below the x-axis? Below makes more sense, okay? And then I'll just connect these using a smooth curve, okay? And then for +1, should it go up, level off, go up? Or should it go down, level off, go down? Up. First one, up, level off, go up. And then connect it with a smooth curve. All right, there's our graph. And I'll just erase the stuff I didn't do so it's less confusing looking. All right, go ahead and make that pile. Yeah, put your test face down in the pile. And then we've got our complex roots notes, and we got our second example on the back of the page. This is what we're doing next. So complex roots notes is what we are finishing up next. You do need a calculator today, so if you do not have one with you, go ahead and trade me your keys or an ID or a cell phone. You do need a calculator today. You do need a calculator today. Calculator, calculator. You need a calculator today. You need a calculator today. All right, so when we are finding the complex roots, what is the very first step? You can flip over to the front of your notes. It's probably been a while since you took them. What was the first step? And this is calculator active. What's the first step? Find the factors, but use your calculator to do it. Find the roots. What's another word for roots? What's another word for zeros? X-intercepts. Okay, find the X-intercepts on your calculator. Find the X-intercepts on calculator. Or, if they gave you a picture of the graph, find them on the graph. So we want the actual X-intercepts. So I'm going to take this, I'm going to graph it, 5x to the third minus 17x to the second plus 9x minus 9. So I'm just typing the problem in. I'm going to graph it. I am not going to worry about changing my window so the whole thing fits in there. I don't care about the whole thing. All I care about is the x-intercepts. Okay? So based on this problem, does anyone have a prediction about how many answers we could possibly have? How many answers could we possibly have for this problem? Before we even graph it, how many answers are we expecting? Not one. 3. We're expecting 3 answers. All right. Now, the calculator gave us 1 real answer. So that answer has a multiplicity of 1. That answer happened 1 time. I can tell because it went straight through the x-axis, which means that 1 of the 3 answers is real. And we're going to use this process to find the 2 imaginary answers. So 1 real answer plus 2 imaginary answers makes 3. Does that make sense? 3 answers total, okay? So that x value, what does that look like? Looks like it's going to be 3. So I'm just going to verify that it's 3. You can either do second trace option number 1 and plug in 3 and just verify that it gives you an output of 0. Or you can do second graph and look at the table and make sure that when you plug in 3, that 3 gives you an output of 0. We just want to make sure we don't have a typo in there, that we actually have the right value. Okay, so the real answer I found, x equals 3, because the title for today was finding real and complex roots. So that was the real answer right there. Okay, now complex roots, like I said in the video, they always come from the quadratic formula, so you always get them in pairs because the quadratic formula has a plus minus in it. And the complex answers come from square rooting a negative number, like you have a negative number underneath the square root sign. That's where the I comes from. So they have to come in pairs. There has to be two of them, okay? Yeah, Court. Yep, that's the only intercept we can see. All right. Any questions so far? We good? Okay. So if we know what one of the roots is or one of the factors is, what did we learn about synthetic division or the remainder theorem or all that stuff? What did we learn about it that could help us find the other ones? Say it again. Yeah, it's the remainder would be 0, right? Because it's a factor, the remainder would be 0. But if we know what one of the factors is, how could we find the other ones? Divide. You can divide, okay? So we know one factor, let's find the other ones. We've got 3 is what's going to go in the little box. And I'm doing synthetic division, but do I have to do synthetic division? No. So if you are not a fan of synthetic division, if you want to do long division today, you are welcome to do long division. So I've got 5, negative 17, 9, and negative 9. This is a factor. Today we're going to have only real factors. X-intercepts are real factors. So the remainder has to be 0. And I always know that I drop down my first number. That what should be 9? All right, let's go through and do this problem. So drop down the 5. 5 times 3 is 15. Negative 17 plus 15 is negative 2. Negative 2 times 3 is negative 6. And then you add them, and then you get trace. Okay? And then 3 times 3 is 9. And then you add those and you get 0. So if this was x to the third, what is this one going to be? X to the second, and then x, and then no x. So we have 5x to the second minus 2x plus 3. Now, we know this is not factorable, because if it was, it would have shown up as more x-intercepts. Okay? It's not factorable. If it was, it would have shown up. So at this point, we have to do the quadratic formula. There's no other way to solve it. Okay? If we were doing a regular remainder theorem problem like we did last week, at this point, we'd be like, oh, let's see if we can factor it. Maybe this is an easier problem. So at this point, you usually have two options. You'd be like, oh, maybe I could factor, maybe I could do quadratic formula. But either way, we're going to try to solve this. Today, because we're looking for complex roots, because I can already tell there's no more x-intercepts, I know that today it has to be quadratic formula. Okay? So first step, find the x-intercept on the calculator. Second step, do the synthetic division. Since this only had one x-intercept, it was only one step of synthetic division. If you had 5 x-intercepts, I'm not evil, so I did not do that. But if you had 5 x-intercepts, you would do that synthetic division 5 times. Okay? Yes? Quadratic formula gives you 2. So we're about to get 2 from the quadratic formula, plus the 1 we had originally is going to give us all 3. Okay, so we've got 5x squared minus 2x plus 3. Quadratic formula, I'm just going to write it real quick, is x equals negative b plus or minus b squared minus 4ac all over 2a. It has to give us a negative underneath the square root. If you don't get a negative underneath the square root, you did something wrong. Because again, if it had been real, we would have seen it. It should have shown up already, okay? So the negative of negative 2 is positive 2. So where b is negative 2. So negative of negative 2 is positive 2. Plus or minus negative 2 squared. Remember, we're putting that in parentheses because we're not trying to kill any otters. Don't want to kill any otters today. Minus 4 times A times C, all divided by 2A. Now, I'm not going to plug this all in at once because I am expecting a negative underneath my square root, so I'm only plugging in the discriminant. Negative 2 squared minus 4 times 5 times 3. And what do you guys get when you type that in? Negative 56. Okay, what do I do with the negative underneath the square root? Yeah, make it positive, stick an I in the front. And so I'll go ahead and write my real answer is x equals 3. And then my two imaginary answers, I have 2 plus I root 56 all over 10, and 2 minus I root 56 all over 10. And there's my three answers. All right. How are your brains? So the process for today is graph it to find the real x-intercepts, do synthetic division, do the quadratic formula, get an answer with an I. Okay? You have a prediction in the beginning of the problem of how many answers you should get. If I remember correctly, there are a couple problems on the assignment where you predict there's going to be 3 answers, and then you graph it, and there are 3 x-intercepts. What does that tell you? You're done. They're all real. You're finished. For all of them? No. For a couple of them? Yes. Okay. One more thing about the quiz tomorrow. It is all calculator inactive, which means that for a problem like this, I would give you a picture of the graph. I would give you a picture so you could just look and be like, oh, the x-intercept is 2. Okay, I'm good. And I would make it so the quadratic formula problem had numbers that were small enough that you could reasonably do it by hand. Does that make sense? So the reason I'm doing it calculator inactive is because we've got these synthetic division problems that I want to make sure that you can do without being dependent on a calculator. Does that make sense? So just like, oh, I can do these problems and I'm not like doing like 2 plus 2 equals 4, just making sure that I know how to add to 4 correctly. Or like, oh, if Miss Rice said this is an x-intercept or whatever, I can use the synthetic, the idea of remainder theorem, and I don't need a calculator to tell me something. I can actually use that idea and do it as well, okay? I did have a request to get those remainder theorem assignments back today, so I'm going to get those graded and get those back to you as soon as possible, okay? All right. Let me get you the